Welcome to qnawire.
So we have a lawn roller that says is in the form of a thin-walled hollow cylinder with mass M, and is pulled horizontally with a constant horizontal force F. Applied at the handle attached to the axle, it rolls without slipping. Find the acceleration and friction force. Well, this is kind of a little bit artificial in the sense that we have, I guess this is a hollow cylinder, so there's no end caps on here, because if we had end caps, that would obviously add to the mass moment, and we don't know exactly how the weight is distributed between the end caps and the cylinder. So we'll assume that there's no end caps here, or that their weight is negligible compared to that of the cylinder. And that could well be the case, because those are at 1/2 the mass of the end caps times r squared, and we'd have two of them, so mr squared, and compared to capital Mr squared, and so this is the this is the mass of the cylinder, and this is the mass of the end cap, each end cap. If this thing's much bigger than this, we can neglect this, but really, it seems like it isn't in a realistic situation. That's probably not a good assumption. But anyway, so we're just going to assume that this is a cylinder with no end caps. So J, the mass moment, is just capital Mr squared, where r is the radius of this. So we have our free body diagram here. We have the weight, the normal force, the friction force, and the applied force, saying counterclockwise is positive. A force balance in the horizontal direction says that F minus the friction force equals the mass times the acceleration. Rolling without slipping says that A equals R alpha. And then taking moments about this point, we just have F times R is the only moment about that point. All the other forces act through that point. And that equals the mass moment times the angular acceleration. Now, let's see, what did I do here? I solved for the friction force here. I substituted this in, and I got F minus JA over R squared equals MA. If J equals Mr squared, we just get F minus capital MA equals capital MA. So A equals F all over 2M. So it's basically, it's half, the acceleration is half of what it would be if this were just sliding. Because we're putting work into causing it to rotate also. Now the force, or the friction force they asked for here, obviously we can figure out, that's pretty easy, that it has to be positive. And again, we can go back to here, and the friction force is JA over R squared. Here's J. A, we know, we can plug that into here. R squareds cancel out. And we just get MA, and that is A is F over 2M, so we get this friction force is F over 2. So half of the force, half of this force is actually being used here to essentially keep the wheel rolling without slipping. Which makes sense, because basically half of this force is causing it to accelerate and half of it's causing it to roll. You can think about it that way, I suppose.